Hello, welcome back to my channel. This is a presentation on the concept of immutability. And this has come up more and more often when people are talking about programming languages and modern coding. And I thought it'd be kind of good to maybe provide some background and analysis on the concept and provide I think some interesting perspectives on it, as well as some maybe opinions on why it is often overhyped in some cases, and how to balance that with kind of the realities of how programming works in general. So what this kind of came down to is more often you might hear someone just go off and say doing certain types of things in certain types of domains, but more often you'll hear this thing where somebody will say, well, mutability is bad, and then there'll be a lot of people that kind of nod their heads, or they'll say like mutability is evil, or if they're being generous, a necessary evil. But you'll still hear a lot of this, and then a lot of people just become like, okay, yeah, sure, I heard that too, that makes sense, and no one really will raise their hands and go, but why? And they don't want to do because they don't want to seem to derail the conversation or show that they're ignorant or don't know something that seems so obvious. And not only that, but there's always time to Google it yourself and figure it out. And so people just kind of eventually take this kind of stuff for granted. And if they hear it enough and see it enough in certain types of documentation, they'll just kind of put it in their head. Mutability is bad. Now, they may not have a good understanding of what mutability and immutability means, but they'll just kind of, you know, it'll sink in there. And, they'll look at it and they'll be like, okay, and stuff like that. So the question is, why is this becoming more popular? And the reason being is that the functional programming is all the rage. And TypeScript is very popular. It's growing in popularity and usage by a large amounts, and that ultimately is a functional programming language. It's not a very good one, but it is still a functional programming language with some interesting features. Don't get me wrong. And not only that, but there's a lot more discussion about this. Like, people are going off in streams and comment boards and stuff like that and talking very serious. It's like, well, I really like time to learn about Haskell. And when I was studying in the 90s and 2000s, I would never have thought that people would be, day-to-day programmers would be like, you know what, I would really like to learn more about Haskell. And some of them are also like, hey, Elixir is really awesome. And I want to learn more about this. And that's also, all of these are based on functional programming paradigms. And when I was studying, even up to where I was finishing my PhD, functional programming was kind of seen more as an interesting academic research area and something with a lot of potential, but something that never really was going to get adopted in the mainstream. And then a few years after that, the interest in it just exploded. And now it's kind of one of those things where it's kind of on the tip of everybody's tongue. And in some cases, people are saying it as like, it's the next, this is the next big thing. Almost like people were talking about object-oriented programming as the next huge thing, which it was very impactful. But people always say, hey, functional programming is going to be really impactful, it's going to be big. That being said, functional programming is all the rage, and I use that in the second meaning of the word. TypeScript or JavaScript has a lot of weirdness galore, and not only that, but the tooling behind it is getting really slow as the code bases increase in size. So much so that they basically had to stop bootstrapping the TypeScript checker itself, which was originally written in TypeScript, which is a lot of people do. When they're coming up with a new language, they will use it to bootstrap its own tools, just kind of as a way to test and make sure it's working well for general purpose programming. There's some exceptions. There are some languages where they were never intended for that, so they don't do that. The tooling's in another language. Scripting languages are a good example of that. And so, but basically, it's gotten to the point where it's, you can literally, if you're trying to go to some code bases, do things like autocomplete, it'll take seconds where it should be instantaneous. And not only that, but your language server will often just crash because it just hit some weird bug and something happened. And so it's becoming increasingly harder to use. And as the type bases have gotten bigger, and the thing about it is that in terms of large code bases, what TypeScript is dealing with is not necessarily enormous. It is kind of expected, for example, that a C#, C++, Java, and all types of stuff like that should be able to deal with tens of millions of lines of code and maybe even hundreds of millions of lines without falling down completely. And TypeScript, when we're just looking at even something that's approaching like close to 1 million lines, which is a lot, obviously, and don't discount that, but obviously it's just starting to really kind of, the cracks are really showing there. Now, for the people that want to learn Haskell, is great, but basically what they'll do is that they'll eventually bump into this thing called monads. And monads are fiendishly elegant and simple. Very simple. Just a very, very methodical application of category theory to a certain type of problems that makes things better. Okay. I will do another video to follow up on this and what a monad really is. But the thing about it is that a lot of people will go in and say, well, it's really simple. It's just like, I've heard some people, like I think the Primogen once called it, like, it's just a burrito. The problem is that it kind of begs the question, well, why do you have the burrito in the first place? And that's where it gets really kind of complicated. And the short answer is you actually don't need the burrito unless you want to have a very strict notion of what your programming language is. But that strict notion doesn't necessarily have to be there. And Elixir, in the end, Elixir is Erlang, and that means that there's going to be some just fundamental limitations to what you can do without just going to ridiculous amounts of trouble. And there's certain domains in which are very popular in which Elixir just won't be a good fit because of that. Because ultimately it is Erlang, and Erlang does put in some restrictions on what you can do without just basically basically going off to unsafe code and just using C and hoping for the best. So the good things about immutability is strict immutability enforcement. So enforcing immutability allows us for large levels of concurrency without having to deal with locks. And not only that, but work on immutable optimizations, how to optimize immutable code, and the related algorithms and data structures have come a long ways, especially in the last 10 years. There's been a lot of good work being done on that. But most importantly, the main thing that's happened is that it's a lot easier now to trade memory for concurrency and simplicity than ever before. And there's more demand for that. You can have a program use more memory as long as it handles more concurrent requests, and you can fit more of them into a box, because you can more easily up the memory on a box than you can really get more single-threaded performance out of a newer set of hardware. And so this trade-off is like, well, okay, we can't necessarily go much faster on each individual bit, but we can handle much more concurrent requests. So that demand has become more and more important as time has gone on. The immutability thing, the not so good thing. Now, some people probably would stop me here and say, I have a ton of videos on Racket, which is a functional programming language. And I've got a lambda in my logo, which is kind of saying, hey, I'm in the functional programming club. I know the secret handshake. And so you can't possibly, with a straight face, go on and say, well, immutability is just an overall win, right, in the long term. And the answer is no, I will actually go ahead and maybe get kicked out of the club for the following reasons. And the reason, one of the main ways to explain this is it kind of provide this in a real world context. And for example, if I'm having a conversation with someone who said, oh, mutability is bad, and I said, well, what about the operations that are not idempotent? And if the person is kind of like, oh, well, okay, that's interesting, but you do this, that's an interesting discussion. But a lot of them would be like, wait a minute, what do you mean by that? And idempotency is kind of where immutability comes into is kind of important, is where you can do operations multiple times and define them in a way so that it's the same thing as just doing them once. And functional programming kind of has that, when you're using immutability, has that kind of notion, whereas if you call a function and you give it the same amount of same parameters as input, you should get the same output, right? If it's strictly immutable. And that's why you can do things like get better concurrency. But in the real world, there's a lot of operations that that cannot happen. For example, if I send out 0 or 2 orders of something from an e-commerce site, when someone paid for just one of those things, that's bad, and that's very hard to fix. And it's the same type of thing that basically, if I shipped out an order that wasn't actually paid for, that's really bad. Now, when I was taking databases, there's a lot of talk about, well, why do we have to do things like make sure that transactions really work? Why do we have to worry about what we call the ACID properties? And the reason is that we looked at it, it's like, well, why can't you use compensating transactions? And the type of thing was like, if you have a bank account and you accidentally removed $100 on it, well, you could just add the $100 back and get the balance to where it wasn't 0. But what that doesn't notice is like, well, the reason that it went down $100 is because you spit out $100 in an ATM, right? And if you didn't do that, you want to make dang sure that you didn't deduct $100 on it their bank account and then try to set it back, because now they're going to go and say, hey, you made an error, right? You charged me, you said I took $100 out of an ATM, but I never got that $100. And so you have to kind of make sure that some operations really do happen. And that means some state has changed somewhere in some file, in some database, in some kind of thing. There has been where your bank account is now this, not that. And that's just the way it kind of works. And so when you have that kind of stuff, it means that the real world is full of the operations that are doing this. And in general, what happens is that we do computation so it does change something. It displays something on a screen. It does some I/O. It puts some new blocks on a disk. It changes the state of the world. And if it doesn't, it really doesn't need to be doing, because at some point there's no point to saying, well, I can say that 7 plus 3 is 10 a million times, and that's functional programming, and that's immutable, but doesn't really provide a real world value to anybody. So getting back to this is like, okay, well, why does people claim that immutable is better? And I said, well, it allows for better concurrency. I also did talk about things like it allows for certain types of formal verification. There's good reasons for that because it's really complicated. And I can get into this a little bit more detail. And what it comes down to is this is another people argument. It's really simple. When you have mutability, this implies you have a before and after. There is something that was this, and now it's that. And now there's ordering in this case, because you have since you have a born out after, you can order things in time, so to speak, and that reduces concurrency, because in some cases you have to enforce the order because you have to say this, then that must happen. And that means that you have to introduce things like locks and atomic types of things and all these primitives for concurrency. And there it is. And that really should be enough to get you to understand what's going on here. But if it doesn't, you're still getting some of the real world complexities, because basically it's one of those things where, again, if you think about it, it's like, well, wait a minute, aren't things just in the real world ordered? And the answer is yes. And that's the thing, is the amount of concurrency that we ultimately can exploit in a programming language in a programming environment is potentially unlimited. But in reality, the amount of things that we can do concurrently or parallel is really is not 100%. And what makes that interesting is that there's something called Amdahl's law that says, okay, well, if you can't have 100% parallelism, how much can you expect of speeding up things if you have X amount of parallelism? And it doesn't take a lot before you get like 95, 96, 97% parallelism, where you could throw infinite amount of processors or something, and you won't get anything more than 30 times faster. And so there's that limit to concurrency in the real world, just because things are ultimately ordered. And the thing about that is that it's not that immutable state doesn't have a lot of advantages for reasoning about programs and doing some stuff. And not only that, but it does allow for a certain amount of concurrency, as well as what people would call non-blocking code, where it enables code to at least not spin waiting for things to happen. But in a lot of discussion, people look at this and say, hey, if you use immutable state, it's this fix to a large set of problems that we're all dealing with. And that's just not true at all, right? It's another tool that we have in the toolkit, but it's not an end-all be-all fix that some people make it out to seem that it's going to be, if we just look at it from a new mindset, or we just do the right thing, or just take a look at it. Or there's a lot of hand waving that goes on there. It's like, well, no, we'll take care of this later on. Now, of course, people will now kick me out of the Functional Programming Language Club. No more lambdas for you, haha, turn in your badge. You should never write any more racket expressions. And, that would be sad. But again, it's one of those things where that really comes from a fundamental misunderstanding of what functional programming means. And what this comes down to is that there's a lot of people going off and talking a lot about functional programming, what it means, and their main exposure to it has been, they have written TypeScript for 4 or 5 years. And that's a completely different beast of someone who's studied multiple languages and well as programming language semantics as a specialty. So, but they will do this. Some of them will point out and say, hey, well, you know what? I took this in college. And this is kind of interesting to note, because it is important. We all know, if you know about the Church-Turing thesis, that this lambda calculus, which is what pure functional programming languages are based on, is Turing complete. So we know that this mutable state is not needed. We don't need to have the Turing thing where it has an infinite state and we write over it, and we just don't need it. That's absolutely correct. Okay, it's a thesis. It's not just an idea, it's a thesis. But possible does not mean easy or equivalent. And that matters a lot in the pure practical standpoint. And what I mean by that is programming languages all make trade-offs in expressiveness, what they're really good at and what they won't be so good at. And there will be some things that are very, very easy to do in one type of programming paradigm that are much more difficult to do in another paradigm. An example of this is I can make a hierarchical state machine using a set of immutable data structures and using higher order functional programming in a pure way. I can do this. Now, that being said, doing it effectively at a certain scale, you just need to have mutable state, because the memory, what will happen to you is the amount of memory pressure will just explode, and explodes in a way that all the tricks that we have to deal with it in terms of garbage collection and stuff like that really fall down, because the garbage collectors have a hard time finding out what's dead. To be perfect, basically what it comes down to is that the underlying data structure is so out there and they're so enmeshed that it has a really hard time finding what the dead cells are. And so there's so much overhead in garbage collecting that it doesn't become very, very practical. Now, on the other side is what you can do is that you can do things, which is what I worked on with UML. Is there's some people that said, oh, I will use UML as a visual representation, but really a high-level representation of a state machine, and it's hierarchical, and I'll do that. And then I will literally compile that against the C runtime. And I'll do this in a highly imperative manner, and it runs very quickly, very fast. You can do a lot of interesting optimizations on it, and there's a lot of domains in which that is still used one such or another. Avionics is an excellent example where they have some code like that, where literally that there's basically, oh, we target this runtime, and since it's a state machine, we know that it's going to take a finite amount of memory to run, it's going to take a certain amount of time for each state transition to happen, and you can do a lot of analysis on that, and you're not doing it in a pure functional way, you're doing it in a much more targeted, low-level imperative environment, because you're targeting an embedded processor at some point. And so certain kind of programs do require certain paradigms to really be effective. And just because you can do something doesn't mean it's practical. And so that's where, every programming language and every programming language paradigm comes into its own. What's interesting about this is that for the longest time, the trade-offs that went against pure functional programming were obvious enough that the more imperative languages like C, C++, and their offsets like Java and C#, and also languages like Python and so on, really won because they just had the performance was necessary. Nowadays, there's more optimization around immutable state. We can tame memory pressure, and we also just need more concurrency out of things to get better performance, because we just can't squeak more out of raw single thread performance without doing some, and in certain cases, there's people that are really interested in doing data level, parallelism, SMD stuff. And that's another area which there's more and more improvements on. But when it comes to certain types of things, the only way we're getting things better is being able to handle more of a thing per computing resource, because we just can't get the raw single threaded performance bumps that we got earlier on in the 80s and 90s, from when processors would just get that much faster single threaded performance every 2 years or so. What's the interesting thing about this is, again, a lot of the functional language that people use, the functional programming languages that people use day to day, is TypeScript. And not only that, but a lot of them use it in an environment where there's this weird wrinkle. And what it comes down to is that I've noted that really what immutability gives you about this is there's better reasoning, but that's really kind of formalized and more difficult, but also better concurrency without certain mechanisms for locking. And that can be useful, but if you take a look at the environment in which GUI applications run and how you do concurrency effectively there, it's really difficult, because kind of by default, you have this weird threading problem, which is that you kind of have to treat the window itself, or the thing that is basically being updated and presented, in its own thread. You don't have multiple threads running in there, and they need to quickly marshal things back and forth between other processes in there. And initially, when the web was developed, they just had an event loop, much like the earliest versions of the the Mac, basically the Mac operating system and the Windows and the X11, they had this event loop that was just single threaded. And so doing that in concurrency in an event loop, that's different than getting concurrency when you have multiple threads and you have all these things with immutable state. You don't get the same amount of advantages. Now, you can make it so it's a little bit easier to do things like non-blocking code, but you're also adding memory pressure here. And so it's a big question about whether or not using concurrency, because functional programming is kind of where TypeScript wants to be, and other types of paradigms are clunky in it, relatively speaking, like object-oriented programming. So is this really a good thing? Now, there's some people that are on one side where they're saying, clearly this is how you do it. Clearly you use the immutability thing as an obvious win. I would say React is kind of the best example of this. They talk a lot about, hey, well, this is how we view how we do things in rendering in terms of immutability, and we, basically the view is a function of the state, and this is why you have to do explicit state management this way, and why you can't do certain types of things in terms of immutable states. There's other people, and I'm increasingly on this side as well, that basically there's an interesting experiment, but it didn't work. It just basically leads to too much overhead and too much abstraction, and it just kind of leads to a certain amount of bloat because you're not getting any win out of there after having to do the harder thing, which is a little bit more manually having to manage state or just having mutability and just using things like a model view control pattern more effectively versus using a whole new paradigm. And for a lot of people, they're like, okay, well, they think that the jury is still out. And the interesting thing about that is why I bring it up in the React thing. They kind of bring up this idea that, well, basically, we're using immutability, so we're avoiding all these types of bugs. And it's really way oversold. Because immutability doesn't necessarily mean you have bug-free programs. It just necessarily means you're dealing with how you think about your GUI in a slightly different way. And not only that, but you're having to do kind of more complicated operations and abstractions to get it to work in the way it wants to work. And you're fighting it in an environment where you're not ultimately multi-threaded. And not only that, but the thing about GUIs is the amount of wins a concurrency gets you in terms of a GUI is limited by the fact that basically there's only so much that can be done in the background, and there's only so much input that you're getting. Now, that does change a little bit in like modern GUIs, because especially on the web, there is this thing where the web applications and GUIs ingest a large amount of stuff and have to talk to a server to do a large amount of things. So it does need this concurrency, but it's doing it in this world that's actually doesn't do that very well. Compared to just being able to do more broaded threading and just do the whole hog functional programming, lock-free concurrency type of stuff. The browser environment just doesn't allow you to do that. And so this makes it really kind of difficult. And so in the worst case, you're really hampered on both sides. You're not getting any of the advantages of the concurrency wins. And really honestly, and you're increasing complexity and you're getting no performance benefits and whatsoever. And in the worst case, you're actually getting performance degradation because you're trying to do certain things, but you're not realizing you're doing them in the wrong way or a suboptimal way. And the fascinating thing about this is that if you look at a historical context, it's never been either or. It has always been the fact that, and here's the thing, immutability has this thing, but it's more useful in some modern programming. It doesn't mean that mutable abstractions are a mistake or an anti-pattern, or that object-oriented programming was a mistake, if you want to use some hyperbole in that regard. We should have never done this. We should have done this instead. Why did we use all this object-oriented stuff? Because all those major FP languages have talked out aloud for both, including objects. And not only that, but if you take a look at where a lot of languages like C# and later on Java and others have gone is that they've adopted kind of a hybrid approach, and where they've actually done some interesting extensions and grafting, well, not grafting, but actually adding in functional programming paradigms into kind of the object-oriented world. And that works fine, because they're already working on work that was being done from not necessarily, the comic Lisp side of things, but from families like languages like OCaml, and then later on Haskell. And then the F# people did a lot of work to help C# out at Microsoft. And all those languages allow for immutability and mutable state. Even Haskell, which tries to stay as pure as possible, does allow let mutable. Now, that's not the default, And that's what's interesting is that you have to explicitly opt into mutability. And there's an argument of whether or not that is actually a better thing to do in terms of the language. And Racket is kind of on that side than Lisp was even in terms of, actually, we went kind of assume immutable is the default unless you want it. And we really want you to call out when you're using it so it's obvious versus having languages like TypeScript, which kind of developed from JavaScript, but in using the Java kind of way things, kind of assumed that mutable state was the default, so to speak. So that's where it kind of gets really interesting and complicated. But it's never been an either or, like you must be immutable, can't use mutable at all. Except if you put a stake in the ground and say, we're really not going to allow certain types of mutable state. You really can't do this. That could be a big win. And the best example of that is Erlang. The reason Erlang is resilient and scalable to the degree that it is that it will not allow you to do certain types of things. And one of it is that there's a certain amount of mutable operations you just can't do. Unless you want to, like I said, hit the escape hatch, work with a C function, and then bring that stuff back in. You just can't do it. And you have to do things like copy certain types of things. And you're constantly moving and copying between processes and doing these types of things. And you're doing a lot of recursion, less doing loops. You do all of this stuff. And the reason that works is because it allows for things like, it basically allows them to control memory pressure and memory leaks and all this type of stuff. It allows, again, for massive levels of concurrency because you can just spin up all these what they call processes, which are basically these tasks, and then assign them to a thread pool that just do a massive amount of optimizations. And so for certain domains, saying, nope, you can't do this kind of thing. You have to use immutable types of these data structures, and you have to do these certain types of operations, and this is all you can do, and you just can't go willy-nilly use mutability at all. It makes it just incredibly useful and resilient. And that's why, if you use the internet, somewhere you have run, somewhere on the internet, your packet has touched Erlang code. And that will continue to be the case. And again, in some operations where you, like you said, if you need to move data from one end to the other, you don't have to do a lot of transformation or logic on it. You can't beat Erlang. You just can't. It's because it's just designed to make that possible. And it's, again, because it is very opinionated and strictly so, and says, nope, you just can't do this. You cannot do certain types of stuff. And so, again, there's that balance. It's like, okay, if you can actually really go in there. Now, that being said, it makes it a poor choice for other domains. I'll give you an example. This is kind of complicated. Some people say, it's like, well, there's this framework thing that you can do GUIs on. But if you look at that, literally, that's what it's like. Oh, this is a way of taking an Erlang server that serves up HTML and using Electron to show the HTML. But try to write some bindings to, or even write a basic GUI library in Erlang or Elixir. And again, Elixir, because Erlang syntax will melt your brain, but Elixir, and you'll quickly see, oh my gosh, this is impossible. And the reason it's impossible because the domain just doesn't fit. It's just one of those things where you're just doing too much mutation. There's too much things that you're updating and you want to update to make having to do a copy over and over and over again really, really reasonable and perform well. And not only that, but you get none of the advantages of concurrency because you're just swamped by the fact that you just have this GUI foreground process that just needs to use needs to have a lot of computation, and there's only so much you can do in parallel. The interesting thing about the discourse around this stuff is that it's getting more and more opinionated out there. And it's just, the nature of the internet. It happens. People get, have parts about it. But what's frustrating to me is there's a lot of people going off and saying, hey, we know how this works and this is the best thing ever. And they don't have the background in programming language semantics or just some of the concepts here to really be any sort of definitive or even informed opinion on the subject. And that's really hard. It's really hard to deal with those people because they're very entrenched. And the hardest part about that is that for a lot of people that are just trying to get their job done and trying to use some of these things and try to understand them and have these honest questions about why don't we do these things, they just kind of get, pushed off as a skill issue. And what it comes down to is that there is actually no reason for certain domains that you need to use functional programming. and especially in the strictest sense. There is no reason for it. And the irony here is that one of those domains in which this comes up often, front-end web applications, is exactly the domain that a lot of people point out and say, oh, here's where functional programming fell really short, and here's why functional programming languages added things like objects. And so you're going up against this idea that basically there's going to be this breakthrough that's going to happen that's going to allow this functional paradigm to work, but that's still an open bet. And if it pays off, that's going to be awesome. But there's signs that's really not going to. And there's a lot of people that don't want to ignore those signs because they don't want to have to use yet another web programming framework, or heaven forbid, actually get some of this standardized to the point where it just lives in the browser and you can just use it without having to go some third-party framework or library or whatever the difference between those two is. I can't even tell anymore. And that's, just awesome. And not only that, but heaven forbid that, you actually get to the point where it's like, oh no, you don't have to use JavaScript as the end-all be-all when you're dealing with the DOM. We actually finally mapped how you can access things from WASM. We can actually just, have that and have a better abstraction for that. So you can even use your own set of languages that better solve your problem, just versus TypeScript being translated into JavaScript and then ultimately run on your browser, or actually interpreted. So that's the thing is that there's a lot of resistance to how to make things better. And I know that certainly, that's where people would drag me on the internet. They really had, if enough people were watching and I had enough visibility, which I don't. But I really see that being the case is that they're arguing for something that has benefits in domains that doesn't apply to the problems they're trying to solve, and they keep trying to wedge it in as if we just keep trying to push hard enough and do the more magic or make it more clever, it's going to work, versus just saying, you know what, this is just not working as well as we should, and we need to kind of rethink these things. And not only that, but really think them from the bottom up in terms of, basically what it does is that they treat JavaScript as basically they see JavaScript as and basically you have a nail, and therefore the only way you can do things is hammer them in, and not realizing that there are other ways of doing things that aren't just hammering nails into wood. So anyway, if you made it this far, thanks for watching. I will have another video coming up a little bit more on around modads and some of the other concepts there as well. And I'll see you in the next video.